In this video, we're going to explain why x to the 0 equals 1. Now, you may have seen this property before, that anything to the 0 power equals 1. Anything. So 2 to the 0 power equals 1. 10 to the 0 power equals 1. A negative number to a 0 power equals 1. A fraction to the 0 power equals 1. Any number to the 0 power equals 1. Why is that? I mean, that seems a little bit odd. With any properties, it's really helpful to understand why something works. So let's take a look at some patterns. Let's go ahead and just look at this base of 2. And we know some things about exponents, right? We know how to do 2 to the 4th, 2 to the 3rd, 2 to the 2nd, 2 to the 1st, and we're wondering about 2 to the 0. So let's take a look at this and see if we can see any patterns. All right, 2 times 2 times 2 is 8. 2 times 2 is 4. 2 to the first power is 2. And now we're trying to speculate what 2 to the 0 might be. So look at the pattern here. When we decrease the exponent by 1, we're dividing by 2 to get the next value, right? Every time we decrease the exponent by 1, the outcome, the value of the expression, is divided by 2. So if I continue this pattern and I divide by 2, yeah, that would have to be 1. And as a matter of fact, for negative exponents, this pattern keeps going. Right? So if I divide by 2, again, I would end up with a half, and we could continue this pattern. All right, so in general, this is going to be true for any exponent. If we say, or any base, x to the 4th, x to the 3rd, x to the 2nd, x to the 1st, x to the 0, here I would have to divide by x to get the next value. Divide by x, divide by x, divide by x. So if I take x to the 1st divided by x, well, that's going to end up being 1. So you might try this again with some different bases just to convince yourself. Like maybe try this with 10 to the 4th, 10 to the 3rd, and see that you're dividing by 10. All right, let's look at another reason why anything to the 0 power must equal 1. If you've been studying exponents at all, you know we have some properties of exponents. And here's one of those properties. If I have x to a power times that same base to a different power, the result is x to the n plus m. All right, so for example, if I have x to the 2nd times x to the 3rd, that's x to the 5th. If I have 7 to the 8th times 7 squared, that's going to end up being equivalent to 7 to the 10th. All right, so let's say I have an x to the 0 involved here. So let's say I have x to the whatever. Let's just keep it general. Let's say I have x to the nth times x to the 0. All right, so by this property, I know that has to be x to the n plus 0. So in other words, x to the n times x to the 0 has to be equal to x to the n. All right, so what would the value of that have to be in order for this to be true? I'm taking x to the n and I'm multiplying it by something, and I have to end up with x to the n. In other words, this value doesn't change. Well, the only way that's going to happen is if x to the 0 is equal to 1. Let's look at one more property. How about this property? X to the n to the mth power is x to the n times m. So for example, x squared to the 3rd is x to the 6th. 7 to the 8th squared would be 7 to the 16th. If you're not sure why this property works, I'd encourage you to go watch my video about these properties. So let's go ahead and throw a 0 in there and see what that looks like. So if I have x to the 0 to the mth power, then by the properties of exponents, I would have to multiply those, and that would have to end up being x to the 0. All right, so in other words, I've got some value, and I'm going to take that to a power, and it's going to end up being the same value. And as a matter of fact, this power can be anything. So what number to any power would end up just being that same exact number? Yep, hopefully you're saying it right. This would have to be 1. 1 to any power is still 1. That is the only number where that property is true. So x to the 0 has to equal 1. All right, so these are some reasons why x to the 0 equals 1. Hopefully that helps you remember this property and be able to use it appropriately.